guys, welcome to Tuesday, March 31st. Today our notes should go pretty quickly. You'll have a quiz tomorrow on Google Form, and then Thursday and Friday our notes might take a little bit longer than they have been just to prepare you. So today we're going to identify and name line segments, demonstrate an understanding of regular and irregular polygons, identify the number of sides and interior angles in a polygon, and we're going to graph points on a coordinate plane to form a polygon. You need your math notebook, a pencil, a pen, and your math book. Alright, the first thing I want to talk about is a line segment. So we've talked about a line. Remember, a line goes endlessly in both directions, and we name it with the points, and we put the lines over it. So this would be line AB. We've also talked about a ray. A ray has one endpoint and extends endlessly in one direction. This would be ray AB. And then today we're going to talk about a line segment. So a line segment is a part of a line that has two endpoints. So we name it in the same way that we would a line, just without the arrows. So we could call this line segment AB or line segment BA. So we're going to talk about polygons, and a polygon is a closed figure made of line segments. It can't be open and it can't have curved lines. Okay, so it's just a bunch of line segments, literally anything that you could possibly create. You know, I'm not the greatest at these situations, that has line segments and it's closed and the lines aren't curved. That is a polygon. So a regular polygon has all sides that are the same length and all angles have the same measurement. An irregular polygon, the sides have different lengths or different angle measurements. So this is very clearly irregular. And then you're going to be asked this question, so I wanted to put a note here. The number of interior angles is the same as the number of sides. So, for instance, let me erase this. Let's say that we're talking about a triangle. A triangle has 1, 2, 3 sides. It also has 1, 2, 3 angles. So we can kind of see how these form angles, right? Likewise, I was going to draw a square, but I'm going to draw a rectangle because you guys know I cannot draw it evenly. A rectangle has 4 sides. So 1, 2, 3, 4 angles, and you'll see these little like half circles to represent the angles. I didn't want to necessarily put all of the polygons on here as far as pictures, so it would be a good idea to go ahead and have your math book open to page 128, because it does show pictures of all of these. You will need to memorize this. If you don't know it already, it will come up on your test. So hopefully we know that a polygon with 3 sides is a triangle. A polygon with 4 sides is a quadrilateral. And we will be talking about different types of quadrilaterals, I believe, on Friday. So yes, a square and a rectangle and a rhombus and all of those things are just types of quadrilaterals because they are polygons that have 4 sides. 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, and 8 sides is an octagon. So you could have a regular triangle in which all 3 sides are the same length, a regular quadrilateral where all 4 sides are the same length, also known as a square. You can have a regular pentagon where all 5 sides are the same, a regular hexagon, etc. Or these could be irregular. So we could create a very oddly shaped pentagon where the sides are not all the same length, but it has 5 sides, straight lines, and it's closed, so it's still a pentagon. Okay? All right, that's really all I have for you as far as notes are concerned. I'd like you to pause the video and do numbers 9 through 19, all of them. It's just 10 quick problems on pages 128, 129. Make sure you do that in pencil and come back with a pen. All right, welcome back. Let's go through this. I hope you took note that it did ask you to write the number of interior angles. So that's kind of why we talked about that. The number of interior angles is going to be the same as the number of sides. So number 9 was a triangle, 3 angles. 10, a hexagon, 6 angles. 11, a quadrilateral with 4 angles. 12, a heptagon with 7 angles. 13, an octagon with 8 angles. 14, a quadrilateral, 4 angles. And 15, a pentagon with 5 angles. Looks like I skipped 16 on here. Sorry guys. That's why I started bringing my book up here with me, since I did that one incorrectly. Number 16 is a hexagon with 6 angles. All right, 17. So on 17, it asked you to classify each interior angle as right, acute, or obtuse, and then to use a protractor just to find the anglement of the first angle, angle A. So in 17, angle A measured 45 degrees, which is acute. Angle B was right, angle C, acute. 18, angle A was 101 degrees. Okay, it's okay if you're a little off. Maybe you put 100 degrees. That's okay. And it is obtuse. Angle B, acute. Angle C, acute. Angle D, obtuse. So if you're getting those wrong, try to pause and go back and see if you can figure out what you did wrong. Or if you forgot to measure, I do want you to kind of double check and make sure you really do know how to measure those. All right, so on number 19, angle A was 108 degrees. Again, maybe you had 105 or 110. That's okay. Angle A was obtuse. B obtuse, C obtuse, and D obtuse. All of those angles on number 19 were obtuse. Again, if you have questions, shoot me a quick email. You can do a chat with me on Google Hangouts or Math 1. I don't want to say the time right now because those times are going to be changing, but I will send that out to you. It's a really good idea that you are checking your email probably twice a day. First thing in the morning, or just keep it pulled up, and then again in the afternoon, because we will email you like last week when I had the answer written on here incorrectly. I obviously just looked up the wrong thing and typed it wrong. So I'll shoot you out little things like that in an email. So hope you guys have a great day. Please let me know what questions